Hello everyone, this is John at the Terra Diem Tower. As you may have noticed compared to my last video, we've had a bit of a perspective change. We're in 2D now. Why 2D? Well, as I've been working more on loose material simulation, it was becoming quite time consuming to debug and play with different algorithms. A 2D world is a much simpler model and it allows me to not get lost in the weeds on rendering, navigation, and debugging. Also, all the fundamentals in 2D map to 3D pretty well. The same solutions work and the same issues tend to show up. Anyway, I decided to build a quick little 2D version of the game engine and game, and here it is. And just to reiterate, pretty much everything I'm doing here translates to 3D. And in fact, most of this stuff is already in the 3D engine. I'm just using the 2D engine as an easy way to demonstrate, and that's pretty much where I've been spending my time. So here's what the current algorithm looks like in 2D. I can place sand just like it does before. It mounds up and piles down. The first thing that's different is I've made some basic graphical improvements so that loose material is more continuous. So we turn on recording. If I place a big pile of sand up here at the top of the tower, it flows pretty smoothly through, and you can see there's a gap here, but it's generally flowing a lot smoother than it did before. This turned out to be quite a simple change, simply by expanding a block to be fully rendered if there is loose material above it. So if I go back to manual mode, I can jump up to the top frame. And if I put on simple amount mesh rendering, this basically changes it so that what happens is every block is showing just a level of how much is in it. And you can see what happens is as this is flowing, it actually is broken up. And all that I did is just say, well, if there's something above it, just draw it as a whole block. And this is a pretty good job, actually. Anyway, so if I continue to let this go, the other thing that I did is I support multiple materials in the same block. So now I can add snow on top of sand, and they can both coexist in the same blocks, and they pile up on top of each other just fine. I can also add sand on top of snow, and it keeps going, and it'll add up. The way this works is that within a single block, like you see here, snow is always on top of sand. But between blocks, you can have sand on top of snow and vice versa. The other thing that has been added is support for liquids. So liquids are different from loose materials in a couple important ways. One is that they don't pile up as much. Like sand, if you look at this, you can see over here it has 16. I'm using a reduced number for the 2D version, but it has 16 as a full block, and then it goes down by 4 for each subsequent block, and that sort of gives you that piling. For liquids, it'll just go down by 1. So if I delete a big block here, you'll see that this will flow out into it, and will flow out over a much longer period. In fact, I didn't even delete enough, apparently. You can flow out just a little bit more. The other thing that's different is that liquid doesn't block loose material at all. So snow will pile on top of sand, but it doesn't make a whole lot of sense for sand to pile on top of liquids. So if I put sand in here, even though it has to go down several blocks, it'll fall right through the lava and push the lava up. Again, all materials conserved. So those are the big changes that's been done, and it works pretty well. Certainly from a gameplay perspective, this is sort of accomplishing most of the things I wanted to do. But there still is that annoying graphical artifact. And just a quick disclaimer, for the rest of this video, I'm going to get into the weeds a bit more on the algorithm and what I've attempted to improve it. If that's not your cup of tea, then I apologize in advance, but anyway. Let's take a look at a more pure example of this. I'm going to switch to the Leaky Well. And actually, before I do that, let me not delete all of that sort of stuff. So let me load the Leaky Well. And here we have it again. In our mode, we can let it run. And you'll see that this is the glitch that we're trying to fix right here. Anyway, the reason this is happening is due to the simplistic nature of the algorithm. The way it works is it iterates over all the blocks being simulated and does two things. It flows as much material down as it can, and then any remaining material, it will flow right and left. So right now, nothing can flow down anymore, and because of the piling amount, it can't flow right or left. And it starts down at the bottom, will go this way, and then it'll continue to do that for every row going all the way up. So let's take a look at what this is actually doing in practice. So I'll switch back to manual mode, go up to the top. I'll go to simple amount mesh, it'll show things a little bit better. So if I have, this is flowing out, when this flows out, it will, first, this is going to flow down, and then flow right or left, and then this one will simulate and it will flow right or left because it can't flow down. This continues all the way over here. This will flow right or left if it can, and it would flow into here, and then this will flow down. Well, that will leave this empty and this will leave this full, which is exactly what happens. So the first attempted fix was to do the flowing of all blocks down first. So do everything in the entire world down first, and then flow them to the side. This would prevent the block on the right here from flowing down after it was flowed into. So let's try that out. We'll go back to the beginning, delete the history, go to the next algorithm. So in this case, let's just let it run. Let's see what it looks like. And yeah, that works. It totally works just fine. Everything flows down, and it looks like it was good, and I was pretty happy with this. But it actually added two more issues. So we solved one and got two more. This is easiest to see with lava. Let me reload this because I forgot to record. And if I switch this out for lava, and we take a look at this, you'll see that there's a couple things that are happening. One is that this is flowing way out to the side. It's not just flowing out and down. It's also flowing out more to the side and everything else, but it's certainly doing it very asymmetrically flowing out. The other one is that you see all this jittering that was happening down below. This is much worse than it was before. There's always some sort of jitter that happens, but you can see this a lot more. Let's see if I go down to one of these frames. You can see it's toggling back and forth as I go through the frames. And the reason this is happening is just the nature of how things work. Like in this case, it can't flow to the right, and this flows down, so it disappears. Now it can flow to the, left. Now it flows to the left, and then it is there, and then the next time it can't, and so on and so forth. So it just toggles. To address the first problem, because jitter that's kind of a harder one, I decided to solve that first, where it was just flowing way out to one side. To do this, I changed the simulation to flow based entirely on the previous state. Instead of having the material move from one block to the other continuously, like it would move from here to here and then move from here to here and so on and so forth, it's only on the previous state. So let's take a look at that. I'll rewind all the way to the beginning. And in this case, as it flows out, you can see that it is actually flowing out symmetrically. Okay, we've started adding this gap again. Oh no, we've added a lot of gaps. So this is now super jittery. So it's totally fixing that problem that I was having. It's nicely flowing down, but it is like jittering all over the place. What's going on here? Basically, it's a similar version of what we had before, where it was not able to flow in one direction because it was full, and then the next turn it was able to flow. And this is just because of the fact it wasn't taking into account the changes that were there. So the observation I had at this point was that flowing down doesn't really have the same issue with symmetry. I had kind of lumped it all in together looking at the previous state. But it doesn't have the same issue with symmetry, as the material always flows down, not right and left. And the simplest tweak is to apply all of the changes after flowing down and then before flowing to the side. So let's try that out. And if we run this, you'll see that, yeah, it didn't flow out to the side. It's still flowing out more. And, well, we really haven't solved this jitter issue either. This jitter is still going. So, anyway, there's also another issue, which it actually takes twice as long to simulate this out. Like in this case, like 200 and something frames for this to finally finish settling. Whereas if I go back and try the original algorithm, you'll see that it resolves much faster. It also looks smoother. It doesn't have the jittering. It just has this weird hole. So what next? Well, I do have some more ideas on how to address this. Some are simple, some are more complicated, but for now I'm just going to put a pin in this sometime in the next day or so, as I've spent probably about a week and a half on this, and move to actual water rendering support, which requires some work in 3D. So next time you see me, it'll probably be in 3D, as transparency doesn't really, or translucency doesn't really mean much in 2D in this case. Anyway, I'll always be putting more of the details on the Terra Diem dev blog. The link is in the description. And otherwise, I will see you next time. Thanks. Bye.